I'm going to go over how to solve each of the nomenclature formula questions we had on our quiz the other day, just in case there are any of them that you don't understand. All right, so the first one was given a name and you were supposed to write a formula. So it was chromium 3 phosphate. And the first question you should ask yourself when working any nomenclature problem is this ionic or covalent? Chromium is a metal, which means it's ionic, and the rules you follow for an ionic, going from a name to a formula, it's a two-step process. The first thing you want to do is draw the cation and the anion and show both of their charges. The Roman numeral tells you the charge on the chromium metal is +3. Metals always have a positive charge. Phosphate, the fact that it ends in 8 tells you that it's a polyatomic ion. So you look at your polyatomic ion list, and this is the formula for phosphate. It's safest to put polyatomic ions in parentheses. That will remind you not to mess with the subscript that's part of the polyatomic. Now normally we would do the crisscross or drop and swap, but I want to point something out here. When the charge of the cation and the anion are identical in magnitude, just combine the ions in a 1-to-1 ratio. Remember, the goal is to have the overall ionic compound have an overall 0 charge. And so if they have the same magnitude of charge, opposite in sign, you just put them together in a 1-to-1 ratio. The second problem was a formula, Na2O, and you were supposed to come up with a name. So again, that happens to be ionic. That should be the first question you always ask yourself. And if it's an ionic compound, the most important thing you need to remember is don't use any prefixes when naming it. So the first element simply has the name of the element itself, sodium, and the second element, if it's just, the anion, if it's just an element from the periodic table, has an ending or a suffix of IDE. So sodium oxide is all you do here. Now, when you do have an ionic formula, you do also want to ask yourself whether or not the metal is a transition metal. In this case, sodium is not. Alrighty, so the next one is also a formula, P2O5. I want you to find a name. Is that ionic? The answer to that is no. It is covalent because that is 2 nonmetals. There is no metal in there. So if it's covalent, the most important thing you need to remember is that you must use prefixes to tell the reader how many of each element. So in this case, it would be diphosphorus pentaoxide. Okay, penta is the prefix for 5, and di, of course, is the prefix for 2. And that's it. So covalents are very easy to name. And the next one is a name, nitric acid. All right, so anytime there's an acid, you know the formula is going to start with an H, or at least one H. You don't know how many yet. And if the name of the acid has a prefix hydro, which this name does not, there's one set of rules, and there's an example of that later. But this does not have hydro, which tells you that there is a polyatomic ion in this formula. So you need to figure out what polyatomic ion is in it. So you have to remember that little ditty of he ate ick and got stomach ite us. Okay? So if you have an acid name that ends in ick, that means the polyatomic it comes from ends in 8. So the polyatomic we're interested in is nitrate. Okay? So you look in your polyatomic list, that's NO3 with a -1 charge. And of course you need a hydrogen in the beginning because it's an acid. And you put as many hydrogens as the magnitude of the charge. So this is a charge of 1. The magnitude is 1, so you put 1 hydrogen. Now, of course, in your final formula, you don't want to show any charges because overall it's neutral. So your final formula is HNO3. Alrighty, so the next one is a name, aluminum sulfate. That is not me making that noise. That is one of my dogs chewing on a toy. Sorry about that. All right, so aluminum is a metal. We know that. So this is going to be ionic, which means if we're trying to write the formula, we start out by writing the cation and anion with their charges, and then we're going to crisscross. Aluminum is an element. It's not a transition metal. It's in group 3, so its common ion is +3. Sulfate, the fact that it ends in 8 tells us that it's a polyatomic, so look that up. It's SO4 with a -2 charge. It's safest when you're working with polyatomics and writing a formula that you put them in parentheses. That'll remind you not to mess with the subscripts that are part of the polyatomic ion itself. Now we're going to crisscross charges. So this 3 comes down as a subscript, and this 2 goes down with the aluminum as a subscript. Don't carry the plus and minus signs down. Okay, so it's Al2 parentheses SO4 3. Now you see why you need these parentheses, because you're going to end up often having 2 subscripts right next to each other. Now we have H2CrO4. Now hopefully you can identify that as an acid because it starts with a hydrogen. And if it were a binary acid, in other words, if there were only 2 elements, that's again one set of rules. It would start with the prefix hydro, but this is a ternary acid. It's got 3 elements, hydrogen, chromium, and oxygen. Ternary acids always have a polyatomic ion. So look that up, CrO4. Your polyatomic list will tell you its name is chromate. Anytime there's a polyatomic ion in an acid, you do the He8-ic. So chromate, when you're naming the acid, comes chromic. Okay, 8-ic. So it's chromic acid, and that's it. No prefix, just chromic acid. Now we have a formula. Okay. Is it ionic? Yes, it is. Cobalt is a metal. And then remember to ask yourself, if it's ionic, is the metal a transition metal? Yes, cobalt's in the middle section of the periodic table. So that means we need Roman numerals to tell the charge on cobalt. So as always, the first part is just the name of the element, so cobalt. I put in empty parentheses to remind myself I need to figure out the charge on cobalt before I'm done and enter it as a Roman numeral here. This monster is clearly not an element from the periodic table. It is a polyatomic ion. So I'm going to look that up. I find out that it is called acetate. Now remember, for ionic compounds, don't ever use prefixes. Mono, di, tri, don't ever use those. Okay, so don't get sucked into that mistake. Now we need to know the charge of cobalt. You always figure out the charge in a transition metal, because they vary, by starting with the anion. Acetate has a -1 charge, but there are 2 of them, so overall the anion contributes a -2 charge. Because the compound as a whole has to have 0 charge, it means the cobalt has to have +2. And if you hear that heavy breathing, that is not me either. That is my dog who is now laying on my lap. All right. Cobalt 2 acetate is the name of this. Now we have another acid, HClO2. I know it's an acid because it starts with hydrogen. And it is not a binary acid, it's a ternary acid because it has a total of 3 different elements in it. And so this is a polyatomic ion. I look up its name and I find that it is called chlorite. He ate ick and got stomach-ite us. So this is chlorous acid. Alrighty, this is an ionic compound because lead is a metal. Remember to ask yourself, is it a transition metal? So now listen very carefully. This is one of the exceptions. Lead is not a transition metal. However, there are 2 metals that are not transition metals, but that must be treated as a transition metal. Lead is one of them, tin is the other. So if you see either one of those, you must use Roman numerals, just like you do with the transition metals, because their charges can vary. So lead, that's why it has a Roman numeral, because we treat it as a transition metal. And that Roman numeral tells us the charge on lead in this compound. Now, you have to be careful. The anion ends in IDE. Okay? That tells you it is probably not a polyatomic ion because most polyatomic ions end in ate or ite. So if something ends in IDE, it is 99% of the time an element from the periodic table. So this is simply referring to phosphorus. Phosphorus is in the group that has charge when it's an ion of -3. So when we crisscross, we end up with Pb3P2. That is lead phosphide formula. All right, and now we have the name, chromic acid. Okay, so there is no hydro prefix, which tells us there is a polyatomic present. So now, what does ick go with? Ick goes with 8. He ate ick. Okay, so chromate is the polyatomic ion that was used to make chromic acid. The formula for chromate is CrO4 with a -2 charge. Now, to finish the acid formula, we need to add hydrogen in the beginning. You add as many hydrogens as the magnitude of the charge. The charge is -2, so we need to add 2 hydrogens. Now, in the final formula, make sure you don't show any charges because overall it's neutral. And that's it for chromic acid. So hopefully these will be a little bit helpful. So those of you who want or are required or else want to take the second quiz, I will see you tomorrow.